What's up, math scholars? It is Tuesday, and we are basically taking one more day to just recap all the different factoring techniques we've learned so far, get a little bit more practice in together, get some more buddies up to practice on your own, and then hopefully you'll leave the room being like a factoring scholar, an expert at this stuff, okay? So let's think back to chapter 1 first to recap the old-fashioned technique. The old-fashioned technique is the technique that you use anytime you have three terms with nobody living out front. So there's like an example problem. You would see nobody out front, that A value would be a 1, and you'd have three terms. And the way the old-fashioned technique works is you just kind of brainstorm numbers that multiply to give you the term on the right, that's the C term, and add up to give you the term in the middle, which is the B term. So you've been doing that. You're an expert at that already. The box method, that is the method you use when you have a number out front, like an A value other than 1, and you have three terms. Now, I'm just making these numbers up. That probably wouldn't actually factor, but that's when you would use the box method. Difference of squares is when you have only two terms. And your two terms are both perfect squares, such as x squared minus 16. We just kind of saw that in the warm-up. You would square root both those numbers. One of your binomials would have a plus. One of your binomials would have a minus. Sum of cubes is when you would have two perfect cubes. Now, I am not good at having my perfect cubes memorized, so I actually put a perfect cube list on my board up here. I'll just say it to the people on the video because you can't see it. 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1,000. Anytime you see those numbers, you're probably going to be working with perfect cubes. I actually also put the formulas up on the board for perfect cubes that we're using today. So you don't have to have those memorized. Difference of cubes. Oh, that should be a cube. I'm sorry. It should have been an x cubed. Nobody mentioned anything. Difference of perfect cubes would be two perfect cubes with a minus sign in the middle. Let's go with 216. And then grouping is used anytime you have four terms. It's the only method you can use if you're trying to factor down four terms. All right, so these problems are not in order, so you just have to kind of find which one we're doing. Number 1 starts right off the bat. I need your help. What technique are we using from that list? The box method. Very good. You have that 2 out front. Now, before you start putting people in the boxes, you do want to make sure there's no common monomial that you can pull out front. So is there any common number I can divide out front of those three terms? Nope. So we're ready for our box. Who should we place in this box? 2x squared. Who should we place in this box? Negative 30. You multiply those two numbers together and you get your negative 60. You guys might need a calculator out on your desk today. I needed a calculator on this one when I did last period. Because I couldn't think of the numbers that multiplied to 60 that added to 7. I was trying 10 and 6, didn't quite work. I was trying 30 and 2, didn't quite work. So I just had to divide until I found something that worked. So try it. Try to figure out what works. Everybody figure it out? Marin got it. Negative 12, positive 5. Negative 12 and positive 5. Alright, so we pull out of our first row what these two boxes would have in common, the common monomial of these two boxes. That would be a 2x. I'm going to kind of start my journey around. 2x times 1x would be 2x squared. 2x times negative 6 would be a negative 12x. And then I look at this x here. X times 5 would be 5x. And I like to just verify this last box would work. 5 times negative 6 would be that negative 30. And then it does not matter, I had somebody asking me again last period, it does not matter what order you put your 2x plus 5 and your x minus 6 in. You can put it in reverse order of what I just did, and that would still be fine. Well, that was a nice review of box method. It had been a few weeks, maybe even a month or more. All right, number 7 is up next. What technique should we use? Grouping! Good! Why are we using grouping? 4 terms is our only option when we have 4 terms. You can use your colors if you want. We're going to have a pink group. We're going to have a green group. This is my favorite technique on the list. Alright, what is a common monomial in my pink group that I can pull out front? R squared. Good. You want to pull out everything you can. That would leave me with an R minus 3. Alright, so keep in mind, in our green group, we're going to need to have an R minus 3. So you need to pull out an appropriate number to leave you with an R minus 3, or you just can't do your last magical step. So what should I pull out to leave me with an R minus 3? A positive 6 or a negative 6? That's always the hard decision. Positive 6. And since you're going to pull out a positive 6, I need you to put a plus 6 right here. So you can see that plus sign. All right, my favorite step. Abracadabra. Poof. The R minus 3 is one single group. And then abracadabra, make a new group. R squared plus 6. Now sometimes I like to look at this and see, can I factor it more? And in this case, I cannot. R squared plus 6, first of all, it's a plus sign, not a minus sign. Second of all, that 6 is not even a perfect square. So we are going to stop right about here. Alright, we've arrived at our first perfect cube problem. So I'll see how much you guys learned yesterday from that video. I see the 64 and I see the 27 and I recognize them right off the bat as being on my perfect cube list. So it's your job to figure out what your A value and your B value are. Basically what numbers got cubed to get that 64n cubed. Did you learn yesterday where the cube root button is? Math 4, very good. Okay, so you learned that from the video, Math 4. So everybody do a Math 4 to the 64. You'll find out what the cube root of 64 is. Math 4, 64. What is it? 4. So basically they took 4, and you have to add the n in. They took 4n cubed, and that's what gave them that 64n cubed. Do the same thing with the 27. What is the cube root of 27? 3. Okay. So I'm actually going to write the formula up on the board just so the people watching the video can see it. We are going to be using the a cubed minus b cubed factoring formula. Because that's what we have here, a number being cubed minus another number being cubed. It is a minus b, and then a squared plus ab plus b squared. So it's not the easiest formula in the world to use, but I think we can get through it with using our thinking brains. So for a minus b, you just do 4n minus 3. So that part is easy. Now this is where it gets a little tricky. What is a squared? What is 4n squared? That whole quantity squared. So 4 gets squared and the n gets squared. 16n squared. Very good. 16n squared. A times b would be 4n times 3. 4n times 3 is 12n. And then b squared is 3 squared, so 9. And that's what it looks like. Okay. Whew, we survived our first. We're going to go ahead and do 10 next while we're on this slide. We're going to use what method? Grouping, my favorite, because there's 4 terms. We'll do a pink group. We'll do a green group. So what is that common monomial that I can pull out of that pink group? Anybody know? Z squared. Good. Leaving us with 1z minus 2. Alright, this one is very, very, very tricky. Beware of the double negative. We need to have a z squared minus 2. It's really awkward to pull something away from a positive to leave a negative. You know how you can do that? What we can factor out of that green group to leave us with a z minus 2, negative 16. Very good. because a negative 16 times a negative 2 would provide that positive 30. Makes sense? It's tricky. That's how it has to work to make these groups match. If your pink and your green groups right here that I'm pointing to don't match, you can't do that abracadabra step. You have to start over. All right, so abracadabra, make a single group. Abracadabra, make a new group is how you kind of finish that off. That's a 2. I hate Z's and 2's. They look so much alike. And so I try to put my crossbar through my Z. Okay, so this one's a little unique as well, kind of like that warm-up problem was. What we're left with is 2 perfect squares. It's called difference of perfect squares. So we can square root both of those terms. The square root of Z squared is Z. The square root of 16 is 4. Just need to remember that one has to be a positive 4 and one has to be a negative 4. All right, the next one we're going to look at 17 because it's kind of like unnatural and very, very strange. What's your thoughts on 17? Perfect cube? Perfect squares? Difference of squares is exactly right. This is difference of squares. It's very awkward to think about it, but x to the 6th actually is a perfect square. What times what would give you x to the 6th? X cubed times x cubed. So the square root of x to the 6th, x cubed. So to set up my difference of perfect squares, you're going to make one a positive and one a negative. The square root of 4 is easy. You go with one positive 2, one negative 2. But the square root of x to the 6th is x to the 3rd and x to the 3rd. We had never really seen anything like that, so I wanted to do it together with you guys before I set up my board buddies. All right, people on the video, I think we're going to end the video here, and I'm just going to be doing board buddies with the rest of my with my class in class. If you're at home, just finish the rest of these problems like on your own, okay? And I'll put the PDF of this file on the Polaris as well if you were absent today.